Welcome back. In this session, we will have a closer look at the sources of wastes and municipal waste, focusing on low and middle-income countries. After this session, you should be able to identify and recognize different waste sources, understand the global waste situation, know key properties of waste and their implications in terms of waste management, and finally, understand the importance of data and data-driven decisions. A huge amount of waste is produced all the time every day. Since the Industrial Revolution, most of our activities incur in waste generation: cooking, shopping, working, going to the doctor. Not to mention the waste behind all the things we consume. Waste can be categorized according to the waste source, as follows. Industrial waste, from manufacturing or processing products. Agricultural waste from crops or livestock. Healthcare waste, from hospitals and healthcare centers. Construction and demolition waste. And municipal waste. This course focuses on the latter. Municipal solid waste includes waste originating from households and businesses, such as hotels, market, restaurants, as well as schools, offices, shopping malls and public spaces, which are normally considered as non-household waste. When talking about municipal waste management, one of the first things to know is the amount of waste produced, usually calculated using waste generation rates. The types of waste produced, in terms of organic waste, paper, plastic, etc., are also important and called waste composition. In addition, waste properties, such as the moisture content, the density, and the lower calorific value are also important to design adequate waste management systems, as we will see later. Let's have a look at the waste generation rate from different countries across the globe. Here, the waste generation rate is shown with a gradient of blue, light blue showing countries with low waste generation rates, and dark blue, high generation rates. The African subcontinent, for example, has generally low waste generation rates per person. The same pattern can be seen in South Asia, while in the United States, Europe or Australia, waste production rates are higher. From this map, it seems that people living in high-income countries tend to produce more waste than people in low-income ones. This relationship between income level and waste generation is better displayed in this graph from the Global Waste Management Outlook, on which the x-axis the gross national shows income per capita, and the y-axis shows the municipal solid waste generation per capita in kilogram per year. High income walks hand in hand with higher rates of waste generation. Now it's time to understand how waste composition is affected by the income level. This pie chart lays out waste composition for different income groups. Low-income countries, lower middle-income countries, upper middle-income countries, and high-income countries. Here the composition is shown in percent of wet weight. In low-income countries the organic fraction is significantly higher than in high-income ones. On the other hand, packaging waste, which includes paper and plastic, is higher in high-income countries than in low-income ones. Nonetheless, these generalities are not always true, and the composition of waste can vary significantly depending on the location. It's difficult to determine what exactly influences waste generation and composition, but we can affirm that the lifestyle, whether a person, for example, tends to eat more at home or at restaurants, as well as the degree of urbanization, and, as seen before, income level, all have an impact on waste generation and composition. Another important element to consider is the influence of the seasons. In rainy seasons, for instance, the moisture content of the waste increases significantly, contributing to the impact that the mango and maize harvest season will have on the generation of organic waste. Let's move on to waste properties. The moisture content is the amount of water present in the waste, which is directly related to the density, that represents the amount of waste per volume unit, and the lower calorific value, LCV, which is the amount of heat released during the combustion. The moisture content influences the treatment options, the density influences more the type of vehicle needed for waste collection, whether a compact truck will be needed or not, and the LCV influences the efficiency of the incineration process. Normally, the higher the content of organic waste, the higher the moisture content, the higher the density of the waste, but the lower the LCV. This table shows usual values for these four waste properties for different income levels. The highlights are: for waste density, a compactor truck can usually compact the waste up to a density of 500 kilograms per cubic meter. In high-income settings, as the density is very low, it makes sense to use such truck, but in low-income settings, where the waste is very dense, not so much. For the LCV, a LCV of at least 1000 is needed for an incineration without adding fuel, and a LCV of 1500 to 1650 is needed for energy recovery. That means that if the LCV is lower than 1000, which is usually the case for waste in low-income settings, the waste won't burn if you don't constantly add fuel to it. Waste generation is the very first element of the waste management chain. Knowing how much and what type of waste is essential as it influences the policies and measures for waste prevention. Helps determine suitable waste collection systems by helping choose an appropriate vehicle, for instance. Helps assess the feasibility and scale of treatment options by determining what can be done and what not. Helps to identify recycling opportunities based on the waste that is generated in your municipality. Helps estimate lifespan of landfill. Estimates trends to plan for the future. Let's sum up what we've just seen in this lesson. We briefly saw the different waste sources. Then we looked at waste generation and composition and how they vary by country, by city, and how it correlates to income and lifestyle. Waste properties, such as moisture content, density, and lower calorific value. Remember, the general rule is that waste in low-income settings usually has high organic content, high moisture content, high density, and a lower calorific value. And finally, we looked at the importance of data on waste generation and composition to determine adequate solutions along the solid waste management chain. Thank you for listening. See you in the next session.